In this video, we'll go over section 4.3 and 4.4. So 4.3 is about quadratic functions and their properties. Now, the quadratic functions in general form should have the following format: f of x equal ax squared plus bx plus c. Quadratic meaning that the highest power is the square, right, or the parabola, and make sure that a, the coefficient in front of x squared term, cannot be 0, and the graphs are called parabola. Now this is the general form, but usually if we can rewrite that in the standard form, it's much easier to draw the function and also find the vertex and the axis of symmetry. So the standard form of quadratic function has the following format: is a x minus h, the whole thing square, and plus k. Now h meaning that the graph is shifting to the right by h unit and shifting upward by k unit, right? So make sure you know that this is the minus side, this is the plus side. So the vertex of this function is h and k. So the vertex is the tip of the parabola, right? So h and k. The axis of symmetry is x equal h. So let's say if I have the parabola, something around here, right? Now the vertex here should be h and k, right? The vertex h and k, and the axis of symmetry is the line that divide the parabola into equal half and half, right? So this line has the x coordinate of h, so this is x equal h, and domain, of course, you can go anywhere on the x-axis, so negative infinity to positive infinity. So these are the basic properties of parabola. Now the parabola is opened up like in this case when the a here is positive. So when a is positive or bigger than 0, right here, you have the open up parabola. If a is less than 0 or negative, then your parabola is open downward. And again, this axis of symmetry is called x equal h, because this is the x coordinate of h unit. The same thing here, this is x equal h. And make a note that a quadratic equation is in standard form when you can write ax squared plus bx plus c equal to 0, and make sure that a is non-zero. Now, how to find the x-intercept of a quadratic function? The x-intercept meaning that, let's say you have a parabola, right? And the x-intercept is this point, or where the function becomes 0, because this point you hit 0 on the y-axis. So these are called the solution of the equation, or the x-intercept. So x-intercept is another way of writing the solution of quadratic equation solution. Now, in order to find how many x-intercept the quadratic function has, first is you gotta find the discriminant b squared minus 4ac. So the term b squared minus 4ac is called the discriminant of the parabola. And if you calculate this one and it's turned out to be positive value, then you have two distinct x and x intercept, or two real solutions. If you have 0 for this whole thing, then you have one x-intercept located as the vertex. And if you have negative value for b squared minus 4ac, then you don't have any x-intercept or no solution in that case. The maximum and minimum. Now the maximum and the minimum, they all occur when the parabola is open up or open down, and that is the vertex of the parabola. So the vertex is where the parabola reaches its maximum when it's open downward. The reason because when you open downward, this is the maximum value, the vertex, and when it's open upward, you're gonna have the mean value, right? Because you have the mean here, the vertex. So HK is really, H is the coordinate or where to obtain the max or min. So the H is the location on the axis where you have the max or the min, right? And the K is the Y value or the max and the min value of that max and min. Now let's try this example. So they give you the equation b of x equal to this, right? And then the best way is you have to rewrite them in the form of standard equation, right? And don't forget that the standard form has f of x equal a x minus h squared plus k, and we are having exactly the same form here. 2 is a, 5 is h, and 3 is k. Now, how many x-intercept does the graph have? So in order to find how many x-intercept, we're gonna have to find the b squared minus 4ac, the discriminant. In this case, a is this, right? And b is minus 20, and c is 53. So if you plug in that, you're gonna get minus 20 squared minus 4a and then c, and that's equal to minus 24 or less than 0. And if it's less than 0, then there are no x-intercept. Okay. And will be, or this function have a max or the min value? Because the a here in this case is 2, meaning that it will open upwards, right? So since a equal 2 is bigger than 0, so you have parabola open upward. Upward meaning that you have the mean value. So mean value. So yes, b will have the mean value. And where will be, or this whole function here, reach its max or min value. So where meaning what's x equal, the coordinate of x is what, that gives you the max and the min value, right? And remember the x equal h is the place where you get max and min value. So right, where to obtain the max or min, which is h, and h in this case should be 5. So x equal 5 because h is here. So the min value will occur when x equal 5. And now you know where to get the max, the min value, and you want to get the actual min value of that. So this is asking for what, and what is k, right? K is actually the actual max and min value. So k in this case is 3. So I'll write the min value is 3. The next example, determine the quadratic function holds the graph has the vertex of this and passes through the point. So be careful. We are trying to look for the quadratic function, and we know that the quadratic function has the form, the standard form of a x minus h squared plus k, right? Now we want to find this equation, and we are missing a, h, and k. We need to find these 3 values, then we are done. And we know that the vertex is given as minus 2 and h, and the vertex meaning that h and k, right? The vertex is h and k. So you have h and k, now just plug in here. So you have x equal a, x minus h is minus 2, the whole thing square, plus k, which is 7. Simplify this one, you should get a x plus 2 square and then plus 7. Now you have everything except a, right? You need to look for a. In order to find a, we need to use the point, because this function passes through the point 4 and minus 5, meaning that x equal 4, then f of 4 is minus 5, right? 4 give you minus 5. Now therefore you have to plug into here, x is 4 and f of x is minus 5 to solve for a. So f of that is minus 5 when you have x to be 4. So 4 plus 2 square plus 7. Then you can solve for a. And this is 6 square, which is 36. Alright, 36a plus 7. And then I can solve for a easily. So I move 7 here, so minus 12 equals 36a. And then a, which is minus 12 over 36. Or you reduce this to minus 1/3. Okay. So once you get a, you just plug back in here. F of x, a is now minus 1/3. And then x plus 2 square plus 7. And this is your final answer. The next problem is trying to find the vertex of this equation by completing the square. Okay. So in order to find the vertex of this one, you need to have the equation in the form of f of x equal a x minus 8 square plus k. Then the vertex is just h and k. But this equation here is not in this form, so we need to convert this one back to this one. So there are the steps to do that. First, factor out the leading coefficient from the variable terms if it is not 1. Because this one 4, remember you want the x squared term to be has the 1 in the front, so you don't want a 4 in the front of x squared. So let's factor out that leading coefficient. So I have 4. If I factor 4 out, I have x squared minus 12 minus 6x. Yes, 6 times 4 is 24. Right? And then I keep the other number by itself. So I only factor out the x terms here. So I factor out the 4. Now I have to complete the square of this one inside the parentheses. Okay, x squared minus 6x. So you take the minus 6x here and take the coefficient of that, which is minus 6. Right, you take the minus 6, the coefficient of the x term, divide that by 2, and then square. That gives you minus 3 square equal 9. Now you have to add 9. Okay, so add 0 inside the parentheses, meaning that you have to write 4 back here. Now x squared minus 6x, you want to add 9 to that to complete the square. So you're gonna add 9, but at the same time you must subtract 9 because you don't want to change the function, the original function. So you add 9 and then you also subtract 9, so that means you didn't change anything. But because we do that, we can complete the square of this one. Okay, so now 4 times minus 9 would give you minus 36, and you can bring that to the outside. So I keep 4, I keep the first three terms right together, and then I bring the last term outside. So 4 times minus 9 minus 36 outside, because I want to complete the square of this one. This one is become x minus 3 the whole thing square. So the whole thing inside the parentheses here become x minus 3 square, because we take x minus half of this number, which is 6 divided by 2 is 3, and square the whole thing. Okay, if you expand this out, you're gonna get the whole thing back by completing the square. And then we bring down the 4, and minus 36 plus 5, that's minus 1. So we end up with the standard form, which is a x minus h squared plus k. Now it's exactly the same thing. A is 4, h now is 3, and k now is minus 1. So the vertex should be 3 and minus 1, hk. Okay, the vertex formula. Now, there's an easier way to find the vertex formula. That's you don't have to convert the equation to the standard form. Now, if you are given the quadratic equation, then you can find the vertex by using the x coordinate of minus b over 2a, and y is just f of that minus b over 2a. Now this is easy, right? So we are trying to find the vertex and the axis of symmetry for this function by using the vertex formula. That's easy. So first find the x. So x is what? Minus b over 2a, right? Minus b over 2a. And this is minus b is minus 48. 2a is minus 3. That will be minus 8. And once you have that, you're gonna find y, which is you're gonna find g of minus 8. Oh, this is y, which is minus 3 minus 8 square minus 48 minus 8 minus 185, and that gives me equal to 7. So x is minus 8, y is 7. Minus 8 minus 7. The axis of symmetry is x equal 8 or x equal minus 8. And then they want you to use this one to write the function in the standard form. So you want to write that back in this case. So we need to find a, h, and k, and we already have those. A is what? A is minus 3, right? Minus 3. H is minus 8, and k is 7. Now you can just plug in directly. G of x equal a, which is minus 3, x minus, so we have the formula here. G of x equal a, x minus h squared plus k. A is minus 3 minus h, which is minus 8 square, and plus k, which is 7. And then simplify that one more time. X plus 8 square plus 7, which is g of x, and that is the solution. Okay, now consider this equation, okay? And part A is graph quadratic function by determining whether the graph open up or down, and by finding its vertex, axis of symmetry, y-intercept and x-intercept if any. So from here, you know that a is the number in front of x squared term, or a equal minus 1/2, less than 0. So if less than 0, you know that this is open downward, right? The parabola open downward. And we can complete the square, right? We can complete the square of this one, and let's do that. So First factor out the 1/2 term, right? Again, so let's try that. We have x equal minus 1/2 to the outside. You have x squared plus 8x, and you keep the minus ax on the right side by itself. Now you complete the square of this term. So before that, we take 8, the b term divided by 2, and then square. That gives you 16. So you know that you have to add. Let me throw down here. You know that you have to add 16 on to here and minus 16 at the same time. So minus 1/2 x squared plus 8x plus 16, and then minus 16, so we didn't change anything, right? And minus 8. Now you can bring this term to the outside, so that's equal minus 1/2. I keep the first 3 term, and now minus 1/2 multiplied by minus 16 give you plus 8, right? So I bring plus 8 to the outside, and then I bring down the minus 8, so these are gone. So I can rewrite this using the square of the binomial x plus 4 square, because 8 divided by 2 is 4, so we have x plus 4, the whole thing square for the thing inside the parentheses here, and minus 1/2 is down here, and 8 minus 8 is gone. So if you can find this is the h, and you don't have any k, meaning that the vertex is minus 4, and the k nothing, which is 0, right? Because you always want to write the equation in this form: a equal minus h squared plus k. Minus of minus 4 give you plus 4, therefore the h should be minus 4, and nothing on the right here for k, meaning k should be 0. So this is the vertex of the function. So you're gonna plot minus 4, 0 is the vertex, so minus 4, 0 is here, and you know that this is open downward, so this is the vertex of that. The axis of symmetry is x equal h or x equal minus 4, right? So this is the axis of symmetry, which is here, and the x-intercept. In order to find the x-intercept, you're gonna let the p of x equal to 0, and we are solving for the solution, right? So doing that, we're gonna let this term to be 0, right? So minus 1/2 x plus 4 squared equals 0, and this means that this term is equal to 0, 0, or x plus 4 equal to 0, or x equal minus 4. So we have this one is the x-intercept only, right? Nothing else. So x-intercept is minus 4. You can write this in the order pair of minus 4 and 0. In order to find the y-intercept, you let x to be 0, right? You let x to be 0, and you're gonna find y. Now x is 0, so b of 0 is what? It's minus 1/2. Let's use the original equation. Minus 1/2 0 square minus 4 0 minus 8. So minus 1/2 0 square minus 4 0 minus 8, and that should give you 8. So y-intercept is 0 for x, 8 for y. So y-intercept is 0 and 8. So 0 for x and minus this should be, let's see, 0 0 should be minus 8, right? So 0 and minus 8, 0x minus 8 here, okay? So because this is symmetry with the x equal minus 4, if you have one point here, meaning 4 units from the symmetry axis, 1 2 3 4, now you go 4 units to the left side, you also have one more point because they are symmetric. and then you can connect the parabola down here and then down there, something like that. So that should be your graph. Okay, and you already have one x-intercept, which is here, and one intercept is here. Determine the domain and the range. The domain, as you can see, are the real x-axis, or minus infinity to infinity. The range is how far you can go on the x-axis, meaning that the highest value is 0, and then you go all the way to the negative infinity. So you go from the range of minus infinity up to 0. Okay, right here, minus infinity up to 0. So we go all the way from minus infinity up to 0, which is the highest point. So that should be part B. And then C, determine where P is increasing and where it is decreasing. So increasing, you may have all the way to the left until this point, right? And decreasing is from this point to all the way to the right, or you have all the way to the from negative infinity up to -4 is increasing. So from minus infinity to -4. So all the way to minus infinity, all the way here, going up to -4 is increasing, and from -4 to all the way to positive infinity is decreasing. So -4 to all the way to positive infinity, where the function is decreasing. So that should be the end of section 4.3.